Okay, so we are going to have to find multiple measures of theta that satisfy the equation that we're going to be given. Your calculator will only give you one measure. So it's really important for you to know what value is the calculator providing me. What quadrant is my answer for theta lying in? Can we close the door, please? So first we need to be cautious. When finding angle measures with a calculator, for finding theta, we must consider in which interval theta is being calculated. Okay, so here's the caution. A calculator will only give you a solution, a single solution, in a half revolution. So it won't give you a full revolutions of answers. It won't give you two. It will only give you one solution. So again, caution, maybe you want to write that down. Calculator will only give you a solution in the span of half of a revolution. Okay, so if I'm given the equation, the sine of theta equals some number k. Okay, now usually we would see that the sine of theta equals y, and we would graph it on a graph so that we could look at all of the values of sine. There are restrictions on k. Okay, k for the sine function, or the values of sine of theta, will never be lower than -1 or higher than +1. And so, like if you recall when we graphed the sine function, I'm just going to come over here really quick. So sine of theta equals y, or in this case k, some value k, from -pi/2 all the way to pi/2. The graph will span the entire positive to negative value range. So at -pi/2, your sine is 0. At 0, your sine of 0 is 0, and the sine of pi/2 is 1. So in this span between -pi/2 and pi/2, you'll get all of the possible values for sine of theta. And then, of course, it heads back down. But we've already got all the positive values of theta and all the negative values of theta. Okay, so your calculator, if you're going to find theta, you'll plug in theta is equal to sine inverse of some value k, excuse me. Okay, but the calculator will only give you answers in quadrant. Calculator will always give you answers that exist in quadrant 1 when sine and cosine and tangent are positive, and then it'll also give you values in either quadrant 2 or quadrant 4. Calculator won't give you answers in quadrant 3. Okay, so for sine function, the calculator is going to give you answers over the interval of -90 degrees to 90 degrees, or if we're in radians, from -pi/2 to pi/2. That is sufficient for the calculator that covers all of the values of k that are possible in the sine function. Okay, so that's the half revolution that I'm talking about. And if I was using the unit circle to kind of illustrate, if you don't mind, I'm just going to do that real quick. Over here in the unit circle, if I start at 0 degrees, and I go up to 90 degrees, my sine function goes from, I wrote that backwards, that's 1 to, my sine function goes from 0 to 1, right? But if I just were to continue along that rotation, what happens to my sine function is that it just returns to 0, right? So as I go in a positive rotation from 0 to 180 degrees, I only ever get sine values that are positive or 0. I don't ever get values that are negative. So for the sine function, the calculator is not going to give me answers in quadrant 2. However, if I rotate this direction down to negative 90 degrees, my sine is negative 1, right? So you can see if I'm on my unit circle from negative 90 degrees all the way to positive 90 degrees, I'm going from negative 1 rising to 0, rising to 1, and then if I head back down to 0, back down to negative 1. So that is the interval right here from negative 90 degrees to 90 degrees where the calculator is going to give you an answer. So for the sine function, the calculator value for theta will be either in quadrant 1 if sine is positive or quadrant 4 if sine is negative. Let's talk about cosine. Cosine of theta equals k. Well, what are my restrictions on k when it comes to cosine? Think of the graph. Negative 1 to 1, exactly the same. As I'm rotating around the unit circle, you know your cosine values circulate between negative 1, 0, and 1 all the time. Okay, if I was plugging in the calculator and I was finding theta, I would take the cosine inverse of k, whatever that value is, between negative 1 and 1. However, if I'm on the unit circle again, going back to my picture, what interval is the calculator giving me answers for in that half revolution? So I'm going to grab up my red pen just to illustrate this. Cosine is your x-coordinate, right? So if I rotate from negative 90 degrees to 0 degrees, I'm going from 0 to 1, right? So k equals 0, k equals 1. And then if I rotate up to 90 degrees, I go back down to 0. So I'm going from 0 to 1 to 0. Well, that doesn't cover the negative answers for cosine, right? So for cosine, the calculator wants to give me all of the answers for k from negative 1 to positive 1. So the calculator for cosine, the calculator is going to give me answers for theta that cycle between 0 all the way to 180 degrees, because the answers for cosine from 0 to 180 degrees will cycle through all the way from negative 1 to positive 1. So the calculator is giving you solutions in 0 degrees to 180 degrees only, or 0 radians to pi radians. That is where the calculator will give you solutions. Oops. Okay, tangent. Tangent of theta equals k. All right, so let me ask you something. Can tangent of theta be anything I want? Does tangent theta's range go from negative infinity to infinity? Yep. So k has no restrictions. Any number can represent k for our tangent function. And if we were to wanted to find theta in the calculator, we'd say theta is equal to the tangent inverse of k. So that's what we'd plug into our calculator to find theta. Now, tangent goes from negative infinity to positive infinity. Well, let's take a look at our unit circle again. No, let's not take a look at our unit circle. I mean, we could. Well, tangent is sine over cosine, right? Right? So in this case, up here, we'd have 1 divided by 0, which is undefined. And then if we go 0 divided by 1, we go 0. And down here, we have negative 1 divided by 0, which is undefined. But down here, tangent is negative, right? And up here, tangent is positive. So if I were to graph between negative pi over 2, or negative 90 degrees, and positive pi over 2, or positive 90 degrees, my tangent function would approach those values of negative pi over 2 and pi over 2, and it would span from negative infinity to positive infinity, all of the values of k to infinity in that little section of the graph. So the interval containing theta for the calculator is also going to be like sine function. They're odd functions. So definitely have to be on each side of the x-axis from negative 90 degrees to 90 degrees, or from negative pi over 2 to pi over 2. But of course you have to keep those intervals open because the pi over 2s, the 90s, those are undefined values for tangent. So the calculator will only give you one answer for tangent or sine or cosine or cosecant or secant or cotangent over the intervals that we've listed. Okay, so here we go. When using a calculator to find theta, be sure to keep restrictions in mind. These are the restrictions. If other values are desired, then reference angles or some other method that you decide on your own, you must employ something else. Okay? So I'm going to be asking you for measures of theta, multiple measures of theta over a full revolution. Okay? So here we go. If tangent of theta is negative, did you hear me? Tangent theta is negative 0.4623. And theta is between 0 and 360 degrees. Find theta, all of the thetas, to the nearest tenth of a degree. So the first thing I'd want to be able to make, what I'd want to verify is that my calculator is in degrees and not radians, because I'm being given interval in degrees, and I want my answer to the nearest tenth of a degree. So check your calculator mode. Okay, and let's first find theta. So if tangent of theta is equal to negative 0.4623, then we're going to have to take the tangent inverse of negative 0.4623 to find angle theta. So it equals to the nearest tenth? Tenth, to nearest eighth. So negative 24.8 degrees. Okay, well that's useful information. Let's find theta's reference angle. What is it? Because reference angles are acute, but they're positive. So 24.8 degrees. So there's our reference angle. So here's what I'm going to do. I'm going to come on over here, and I'm going to draw a little picture, and I'm going to make a statement. Tangent of theta is negative in quadrants 2 and 4. Truth? Right? And you could, of course, go and remind yourself of our little a smart trig class. Remember that. So in quadrant 1 and 3, tangent is positive. So in quadrants 2 and 4, it's negative. Okay, so I'm going to come over here with my red pen, and I'm going to go ahead and say, so there's a negative, tangent is negative over here, and tangent is also negative over here. And what I'm going to do is just draw my reference angle. So here it is, 24.8 degrees and 24.8 degrees. And that should be a straight line connecting those two. I didn't do a very good job drawing that. But there are the two reference angles where tangent of theta is negative. Okay? And we are definitely in the interval of a positive rotation from 0 to 360 degrees. So we're talking about positive rotation. Okay, so tangent is negative 2 times, but the calculator doesn't give me both answers. Remind me, where does the calculator give me a solution for theta? Negative 90 to 90. So I'm going to grab my blue pen up, and I'm just going to go, okay, so my calculator solution for theta is from negative 90 to 90. All right, so tangent is negative in quadrant 2 and 4, and the calculator's giving solutions in quadrant 1 and 4. So which theta am I finding? Quadrant 4. Yeah, quadrant 4 is where the calculator's giving me a solution, but it's giving me a negative solution. I don't want a negative solution. I don't want negative theta. I want positive theta. All right, so let's just take quadrant 2 and let's find theta. So theta is equal to, how do I find this value? What do I do? Inverse? It's not inverse. Maybe reciprocal, but not inverse. And no. Okay, so how am I going to find this measure? From here to here. So 180 degrees, you say subtract the reference angle? Because it's short of 180 degrees, right? It's a little bit short of 180 degrees. So that would be 155.2 degrees. That's definitely within our interval of 0 to 360 degrees. And then in quadrant 4, theta is equal to, so I'm a little short of 360 degrees, right? If I'm going in a positive rotation from here to here. So I would take 360 degrees, subtract my reference angle of 24.8 degrees, and I would get 335.2 degrees. So just for those of you that are visual learners, I'm going to draw this picture. So tangent is negative in quadrant 2. So theta is 155.2. And in quadrant 4, so I'm still in a positive rotation, theta is 335.2. Now I'm going to teach you to use your calculator right now to check to make sure your answer is correct. So we're going to do a calculator check. So tangent of 155.2 degrees should equal approximately negative 0.4623. Could you check your calculator, please? So negative, it's not exact because we rounded to the nearest tenth. We'd have to probably go out 10 decimal places or at least 5 decimal places to get it exact, but as long as it's close. What is it? 2, 0. Okay, so that's close enough. See? Beautiful. Okay, and let's check the tangent of 335.2. So you type that in real quick and you get negative 0.46. Help me out. 2 again. Okay, so close enough. And that's definitely close enough because we rounded to the nearest tenth. So we did an intermediate approximation, which will throw off your answer a little bit. It's certainly close enough. So now let's write our final answer. So in the interval 0 to 360 degrees, tangent of theta was equal to negative 0.4623 when theta equals 155.2 degrees and 335.2 degrees. And we verified it with our calculator. Okay. So let's just go over that again. Tangent was negative. So I thought about where tangent was negative in the interval 0 to 360. That was in quadrant 2 and in 3. 4. 2 and 4. I know the calculator gives me the answers in quadrant 1 and 4. So the answer that I was getting was being graphed in quadrant 4. I had to use my reference angle to find the values of theta. Let's try another one. Here it is. If cosine of theta is negative 0.3842, think about what quadrants that happens in. And 0 is less than or equal to theta is less than 2 pi. So that's a full positive revolution, right? Find theta, or theta, multiple thetas, to the nearest 1,000th of a radian. Change your mode to radians. If you don't, you'll be getting answers incorrect. And over here, what I did was I just quickly drew a little circle with a coordinate grid so that we could put the approximation values for radians, because radians at the quadrants are in terms of pi. So you have 0, and pi over 2 is 1.571. Pi is 3.142. 3 pi over 2 is 4.712. And then 2 pi is 6.283. So those are your approximations for radians in decimal form. And I went to 3 decimal places because your answer is supposed to be in 3 decimal places. This will help you to determine where your answers are. Okay, so first let's find theta. So theta is equal to cosine inverse of negative 0.3842, which is equal to, what do you got? 1.965. Okay, that was an intermediate approximation. Make sure you keep that answer in your calculator. All right, so well, is that an acute angle? 0 to 1.57 is acute. 1.9 is way over here, yeah? So we need to find the reference angle. What are we going to do? You think? Because it's over here, right? So we'd have to do this angle right here. We're looking for this angle. So we'd have to do pi minus. So we're going to do pi minus. What I did is I did second, and then I pushed negative to plug in the answer so that I don't get an approximation of an approximation. So that's what I did to get my answer, 1.176. Probably if you plug it into your calculator, pi minus 1.965, you're going to approximate 1.177. Okay, and that'll be okay. So I'm going to come over here. I'm going to draw my graph, or my coordinate plane, and I'm going to think that cosine of theta is negative in quadrants 2 and 3. Right? So cosine, negative cosine here, negative cosine here. But my calculator only gives me answers for cosine of theta in quadrants 1 and 2. So that's my calculator solutions. So where is my calculator giving me an answer? No, it has to be where they overlap. So in quadrant 2. So it's over here. Right? So this is 1.965 radians. It actually is that value. So we already know theta in quadrant 2, but we need the reference angle, 1.176, to help us find the value of theta in quadrant 3. But again, we already know what it is in quadrant 2 because the calculator told us what it was. So in quadrant 2, theta equals 1.965. But in quadrant 3, we're going to have to do some calculations. So what are we going to start with? How do we get from here all the way to there using the reference angle? What do I start with? Pi, and we're going to add, right, the reference angle of 1.176. So theta in quadrant 3 would be 4.318. Okay. So for those of you that are visual learners, theta's first value, I know, is 1.965. We're almost done. And in quadrant 3, using our reference angle, we were able to find theta was 4.318. Okay, so calculator check. We're going to test it, make sure we're right. So the cosine of 1.965 and the cosine of 4.318, plug them into your calculator and make sure, verify that we did this properly and that we're getting an answer that's close. So what was the cosine of 1.965? Beautiful, beautiful. To 3 decimal places, that's perfect. How about the cosine of 4.318? 3842, like exact? Wow, that's nice. So really good answer there. And so we verified that we actually did this correctly, so we can now make a final statement in the interval 0 approaching 2 pi, cosine of theta equals a negative 0.3842 when theta equals 1.965 radians and 4.318. And we will finish the back side of the notes tomorrow because the bell's about to ring, and then we'll do some practice and you'll get some practice.